Hello everyone. Write down circular motion. First of all, let's see how do we define a circle. Technical terms which you basically use for circular motion. If an object is moving in a circular path, then it means it is moving in a path where its distance from a fixed point always remains same. And this much is not sufficient. You also need to add what? Its path should be in one plane. For example, if an object is moving on the surface of a sphere, then also you know that distance from the center will be what? Same. And therefore, technical language for the circular path is, in fact, write down the statement. When an object moves such that its distance from a fixed point always remains same, its distance from a fixed point always remains same, and its path lies in a single plane. Inside the bracket, two-dimensional path. Bracket close. Then we say that motion of the object is circular. Motion of the object is circular motion. Simple technical terms and all, nothing special. Object is moving, and it is moving such that its path its distance from a fixed point. Now, you need to remember fixed. For example, suppose take an example of this. If I rotate this marker, let me ask you first and then I'll explain everything. When you look at the tires of your bike, car, bicycle, anything, any point on the rim, if you take, at the circumference if you take, while your car is moving or bike is moving, is path followed by that point on the rim, is that path circular? Yes or no? Write down in the comment box. Let me see how much visualization you have got. So let me repeat my question. There is a bike. On the rim there is a point, there is a dust particle, and as this bike moves, if somebody asks you what type of path this dust particle sticking somewhere on the rim follows, then will you say the path is circular? Yes or no? Only 2 responses, 3. Good. The path is, it's not circular, remember. Why? Because its distance from a fixed point is not same. Fixed point. Somebody can think that its distance from the axle is same, but that axle itself is moving. And therefore you need to remember, when you say path is circular, such a simple thing needs some spatial attention. And therefore we have added that this C is a fixed point. So you can underline fixed in that statement which you have written. Just underline the fixed part. And later on we'll see that the path that dust particle follows, if you have this thing, and as this wheel moves and also rotates, we'll see this thing later, path of the dust particle is something like this. And it's not a circular part, remember. But just don't worry about it, we'll see this thing later. Now, if I have defined circular motion, then I also asked you to write that this whole thing takes place in a single plane. And once you say single plane, anything moving in a plane means path is what? 2-dimensional. So path which this object follows is a 2-dimensional path. Just like projectile motion, this is also a 2-dimensional path. Now, जैसे ही मैंने बोला कि ये 2-dimensional है, then you know that in projectile motion we used to resolve all the vectors along the x-axis and along the y-axis, be it velocity or acceleration. We always went for ux, vx, vy, ax, ay, sx, sy and all. We can explain circular motion with the help of that technique. We can always resolve its velocity along the x-axis, along the y-axis. Similarly, we can resolve accelerations along the x-axis, y-axis and investigate the whole thing. But that process will be mathematically too cumbersome. Thoda mathematical work, integration and all, geometry and all, बहुत ज़्यादा use करना पड़ेगा. The advantage which we had with this, in this projectile motion, was acceleration throughout was pointing in one direction, downwards. So you didn't have to worry about varying or variable force. Whereas, I have discussed this thing in general before. Everybody has the idea of centripetal force. And what is centripetal force? Little bit of idea I've already given to you. That this centripetal force acts towards the center. So as object's position changes, direction of force, you can see, is continuously changing. And since that direction is changing, it will be difficult for us to simply write ax and ay. Whereas in projectile motion, if you remember, we used to write ax as 0 and ay as minus g. बड़ा easy था. Horizontal कितना है 0, vertical कितना है downwards g, इतना बोलते थे अपन. लेकिन यहाँ प्रॉब्लम क्या आएगी कि कभी एक्सेलरेशन इधर है, इसका a निकालो x, इसका a निकालो y, यहाँ आएगा वो ax और ay चेंज हो जाएंगे. And when acceleration changes, we cannot use Newton's equations like v equals to u plus at and all. And that's the reason, instead of using this approach, we'll be using a different approach जो calculation work को क्या कर दे easy. Answer ax और ay and then writing ax as dv by dt, इससे भी आएगा, लेकिन ध्यान रखना कैलकुलेशन बहुत ज्यादा हो जाएगी जिसमें अपन इंटरेस्टेड नहीं है. सो हाउ डू वी हैंडल सर्कुलर मोशन देन? अब वहां चलते हैं. देखना भाई, कुछ बेसिक पॉइंट्स को ऐड करते हैं जरा. आप दो तरह से सर्कुलर मोशन को डिफाइन कर सकते हो. Suppose the object is moving with v. If object is moving with v, then we say that if a force is acting in this direction, this force is acting along the tangent, and therefore we'll call it Ft, tangential force. This is your tangential force, and this one the force which acts toward the center. A force is acting in this direction. This is Fc. This Fc is called centripetal force. अब बोलोगे सर हमें कैसे पता कि भाई एक फोर्स इधर है एक फोर्स इधर है? नहीं पता अपने को, लेकिन अपने को एक चीज पता है कि किसी भी वेक्टर को which is in a two-dimensional plane, circular path is what? Two-dimensional, and therefore any vector in a two-dimensional plane can be resolved into two mutually perpendicular components. So suppose somebody says that this is a vector, say A. एक आदमी आया उसने बोला ax ay. फिर से कोई जरूरी नहीं था कि आप इसे ax और ay इस तरह से रिजॉल्व करते. एक दूसरा आदमी आया उसने बोला नहीं मैं इसको इस तरफ रिजॉल्व करूंगा और इस तरफ. So the requirement is that the components should be mutually perpendicular. Let's call it ax dash ay dash. कोई आपसे ये नहीं बोल रहा कि आप horizontally और vertically रिजॉल्व करो, आपकी मर्जी है. रिजॉल्व कहाँ करना चाहिए? वी ऑलरेडी नो फ्रॉम लॉज ऑफ मोशन, जहां पर हमारे लिए कैलकुलेशन करना क्या हो जाए, इजी। तो यहां पर हमारे लिए कैलकुलेशन करना कहाँ इजी था? इस ऑब्जेक्ट पर एज इट मूव्स, it is moving under some force. We have no idea what that force is as of now. We are into investigating this force. So we assume that भाई एक कंपोनेंट इधर है और एक इधर है, कहीं भी हो, आप चाहते तो इधर और इधर भी ले सकते थे. You could have taken something like this also. The only requirement is the components should be mutually perpendicular. If you are in a 2D, if you are in 3D, you just need to add what? A third component also. Hopefully you understand this part. So we have taken the angle between the components 90. अब जब ये 90 है तो हमारे लिए बोलना आसान है. What is this line called? Tangent. What is special about tangent? जब भी आप इस ऑब्जेक्ट को देखोगे कहीं भी, at any point, ये ऑब्जेक्ट हमेशा कहाँ मूव कर रहा होगा? along the tangent. इसलिए हमने क्या बोलना शुरू किया कि भाई एक काम करो, एक टेंजेंशियल कंपोनेंट बनाओ और एक दूसरा टेंजेंट से 90 पर. टेंजेंट से 90 पर क्या होती है? रेडियस. कहाँ पॉइंट करेगी? सेंटर. गिव इट अ न्यू नेम, that is centripetal component. This is your tangential force and this is centripetal force. Now ये क्या करते हैं, इनका क्या काम है, अब वहां चलते हैं. But let me see if any one of you can answer this thing. Can somebody tell me the role of Ft? What is special about Ft? What Ft can do and what Fc can do? And the hint is the angle is 90. First tell me what role Ft, F tangential plays. If you can answer this, and you can answer this thing, or a very difficult task. Think about it. Well, I'm asking, what do they produce? What type of change they produce and all? Keep on trying. Whenever I ask you something, always try to answer. Even if your answer is correct or not completely correct, it gives me an idea the way you are feeling everything, and it also increases your confidence that at least you tried something. If your answer is correct, then it's a very good thing. But it's not, just don't worry. At least you tried something. You will remember that you produced this answer and then sir modified our answer. Now, look. आपसे क्या बोला मैंने कि आप यहाँ पर खड़े हुए हो? A few more responses. Let me see. Well, not a single answer is correct, but just don't worry, things are here. मैंने आपसे बोला होता कि आप इधर जा रहे हो, लेकिन आप खुद आंसर दे पाओगे. You're moving this way, and a force is acting in this direction, in the same direction. Moving this way, a force is acting in this direction. Tell me, can this force, forget about this, in this setup, just tell me, can this force change the direction of motion? Yes or no? Fast. Can this force, which is acting in this direction, in the same direction where object is moving, can this force change direction of motion? Yes or no? बहुत सही. It cannot. Now, answer this part. can it change magnitude of velocity, that is speed? Can this force which is acting in the direction of v change its magnitude? Yes or no? Fast. Good. The answer is what? Yes, it can. So what tangential force does, what this tangential force does, it changes only the magnitude. It cannot change direction. Write down this. Tangential force tangential force acting on the object, tangential force acting on the object can never change direction of motion, can never change direction of motion. It can only change magnitude of velocity inside bracket speed. अब इधर you already know these names and all. Let me remove this part. अब आपसे ये बोला गया कि भाई एक ऑब्जेक्ट इधर जा रहा है, लेकिन आपने फोर्स इस तरफ लगाया Fc. आपको पता है कि ये एंगल कितना है 90, और आपको एक और चीज पता है, किसी भी वेक्टर का, now you need to forget this part, forget this thing, this is the only force. किसी भी वेक्टर का अपने से 90 पर जो कंपोनेंट होता है वो क्या हुआ करता है? जीरो. कंपोनेंट मतलब जो वो इफेक्ट ट्रांसफर करता है. तो ये Fc इस तरफ कितना इफेक्ट ट्रांसफर करेगा? जीरो. That means if I ask you this, that can Fc change magnitude of V, then the answer will be no, it cannot. But can it change the direction? सोचने की जरूरत नहीं, आप खुद देख सकते हो. आप ऐसे जा रहे हो, किसी ने फोर्स इधर लगा दिया, तो डायरेक्शन क्या होगा? चेंज. Now look at this. आप इधर जा रहे हो, किसी ने फोर्स इधर ही लगाया, आपकी डायरेक्शन चेंज नहीं होगी, लेकिन जो आपकी स्पीड है वो इंक्रीज हो जाएगी. अगर फोर्स ऑपोजिट होगा तो डिक्रीज हो जाएगी. सो द थिंग इज, this Fc cannot change magnitude, it can only change what? Direction. Write down this. Centripetal force acting on the object, centripetal force acting on the object cannot change its magnitude, cannot change magnitude of velocity. It can only change direction of motion. it can only change direction of motion. So now you know what role these two components they create. These two components, what role they play. You have understood this part. Ft changes magnitude, doesn't change the direction. Fc changes direction, it doesn't change magnitude. I'm asking this. Which component do you think is a must for having circular motion? Write down this in the comment box. Without which component circular motion is not possible? Is it Ft or is it Fc? What is a must for circular motion? Good. This is the correct answer is Fc. क्योंकि आप कैसा भी सर्कुलर मोशन कर लो, Vfc, कैसा भी सर्कुलर मोशन करोगे, डायरेक्शन तो आपको क्या करनी होगी, चेंज. कोई ऑप्शन ही नहीं है. अगर Fc नहीं होगा, ऑब्जेक्ट कहां निकल जाएगा, स्ट्रेट वन डायमेंशनल पाथ. What Ft does, it changes magnitude. So if it is not present, then there will be no change in the magnitude. What does it mean? It means suppose the object starts moving with 8 meters per second. This is 8. If no Ft is present, so here and then we'll write the statement. You can also draw these figures. Suppose we have a setup like this. Object is moving in this direction and its V is 8. And we have been told that Ft is not present. Then it means आप इस ऑब्जेक्ट की स्पीड को चेंज नहीं कर सकते. जब ये यहां आएगा V क्या होगा, 8. जब ये यहां होगा तब भी V क्या होगा, 8. लेकिन आपको दिख रहा है कि डायरेक्शन लगातार चेंज हो रही है. इसका मतलब Fc is all the time present. Fc is all the time present and it acts towards the center, towards the center, towards the center. तो जब Ft नहीं है, सर्कुलर मोशन हो रहा है. किस तरह से? विद कांस्टेंट स्पीड. This constant speed circular motion has a special name, which is UCM. Who can decode UCM? Who will decode UCM? Write down this in the comment box. Let me see कि आप कितने और क्या क्या सोच सकते हैं. Good. This is uniform circular motion. We'll write the statements, but अभी समझने के लिए, अगर Ft नहीं है, स्पीड चेंज नहीं होगी, that is called UCM, uniform circular motion, which is this. And if I will remove this, but before that you can write like this also. In this case, only magnitude of V changes. If you have drawn like this, although we have written the statement, only magnitude of V changes in this case. And in this case, with this only direction of V changes. Note down this fast. Only mod changes, only direction changes. Now look at this second part. In the second part, आप दोनों को एक साथ साइड बाय साइड या जैसे भी आपको ड्रॉ करना है कर लेना. If they both are present, इसी में बना दे रहा हूं, आप अलग से बनाना, मैं ऐसी फिगर के अंदर बना दे रहा हूं. If they say that ft is present, just हमने कोई एक वैल्यू ले ली आपके समझने के लिए, that ft is 2, फोर्स प्रेजेंट है, fc भी प्रेजेंट है. fc तो मस्ट है, दिख रहा है आपको, बिना fc के काम नहीं चलता. लेकिन अगर ft प्रेजेंट है तो क्या होगा, अगर हमारी शुरुआत हुई है 5 से, then this object, let's say it reaches this position. अब यहां पर जाकर इसकी जो v है, this tangential force will increase v from 5, let's say it becomes 7. When it reaches here, it becomes 9, and so on. fc is a must, डायरेक्शन चेंज करेगा. लेकिन ft क्या कर रहा है, it is also changing the magnitude. अगर सेम डायरेक्शन में लगाओगे तो मैग्नीट्यूड इंक्रीज होगा, अगर ऑपोजिट लगाओगे तो मैग्नीट्यूड क्या होना शुरू हो जाएगा, डिक्रीज. दिस टाइप ऑफ सर्कुलर मोशन इज कॉल्ड, नाउ हर आदमी को समझ में आएगा, NUCM, नॉन यूनिफॉर्म सर्कुलर मोशन. Note down these two figures and then we'll write few statements. I had sent a lecture on that maximum power homework which I had given you. If you have seen that lecture completely and you understood it, then write down yes. Although it was not necessary for you to watch that, because I told you that question is for JEE Advanced and all. But in case you had time and you saw the lecture, then simply write down yes. If you have not, don't worry. Whenever you feel free, you can watch that. आपके पास बहुत टाइम है, उसके अंदर जिन्होंने देखा उनको पता होगा कि there are two ways I've explained that lecture. And the second method is something which you will understand when we are through with oscillations and all. But for the first method is about maxima and minima, the way we use maxima and minima. So whenever you get time, कोई restriction नहीं कि आज देखो कल देखो, जब आपकी मर्जी हो तब देखना, कोशिश करना देखने की। So now write down the statement. When an object moves in a circular path, when an object moves in a circular path, it is under two forces: tangential force and centripetal force. Tangential force and centripetal force. Tangential force only changes magnitude, whereas centripetal force changes direction. Whereas centripetal force changes direction. And for circular motion, for any circular motion, and for any circular motion, as direction change is always present, as direction change is always present, centripetal force is a must. You need to have it always. Whereas tangential force is optional. Whereas tangential force is optional. If it is present, speed will change. If it is present, speed will change. Which is called non-uniform circular motion. And if it is not present, then speed will remain same. If it is not present, then speed will remain same, which is called uniform circular motion. Which is called uniform circular motion. Now tell me in which UCN or NUCN velocity remains constant. Answer this. In which case velocity remains constant, UCN or NUCN? Good. Neither in first nor in second. What is V? What is velocity? It's a vector. Magnitude as well as direction. You know that direction always changes, and therefore in UCM as well as in NUCM, V velocity तो हमेशा ही क्या होगी? Change होगी. ध्यान रखना, when you say uniform circular motion, it doesn't mean that velocity is uniform. It only means that speed is uniform. Write down this as a special note. Velocity in both cases, UCM as well as NUCM changes. As direction change is always present. As direction change is always present. Hopefully यहाँ तक की कहानी क्लियर हो गई होगी. अब इस सर्कुलर मोशन में we are interested in UCM, uniform circular motion, but I'll also explain NUCM later on. Right now, everything which you will see, in fact not everything, most of the time will take help of NUCM also, क्योंकि अपने को चीजों को अगर अच्छे से समझना है तो थोड़ा बहुत NUCM भी अपन देखेंगे. बट अभी अपना फर्स्ट फोकस है in UCM, uniform circular motion. So write down the subheading uniform circular motion. Now, in the beginning of the lecture, I told you that we do not. Just a second. Just try to draw this figure also. Forgot to mention this. We had seen that this was FT, this was FC. कुछ स्पेशल नहीं है, लेकिन you need to draw this thing जिससे कि आपको चीजें क्लियर रहें. ये दो अपने पास कंपोनेंट थे NUCM में. बट इट ओनली मीन्स कि हमारा जो फोर्स है वो इधर लग रहा है. दिस इज योर FT. Get me the value of FT. Magnitude of FT. Write down fast in the comment box. FT means F total. Total force. आपको अगर T और C नहीं दे रखे हैं, they are giving you FT, then you resolve them. And I'm asking you, what is F total? Good. So what is F total? जब भी आपके पास दो वेक्टर्स हैं तो आप क्या करते हैं? आप ये करते हैं बस FC square plus FT square. If you have two mutually perpendicular vectors, if they are giving you FC and FT and they are looking for total force, then that total force is this. And you can expect a question like this also. FT is FC plus FT, और ये कई बार हो चुका है भाई, इसलिए इसमें परेशान होने की जरूरत नहीं है. The thing in blue is giving you magnitude, and this thing in black, it gives you what? Vector representation. This is your main force. It has two components, so we are showing these components. Just mention these two things and then we'll discuss this uniform circular motion. सिंपल वेक्टर की कहानी है, कोई स्पेशल पार्ट नहीं है. Now we're discussing uniform circular motion. तो हमने यहाँ पर यूनिफॉर्म सर्कुलर मोशन में कुछ कुछ चीजों को डेवलप किया है. क्या क्या वो चीजें हैं देखना. हमारा ऑब्जेक्ट यहाँ पर है. दिस इज द स्टार्टिंग पोजीशन and then it moves from this position to this position. It is moving like this. जहां भी आप जाओगे जो उसकी स्पीड है वो क्या रहेगी? सेम. क्यों? यूनिफॉर्म सर्कुलर मोशन. And from this position to this position it moves this much, which is theta. ये जो theta है, this is called angular displacement. Angular displacement. In kinematics, in motion in 1D, we used to have what? Displacement. यहाँ पर क्या चीज है? Angular displacement. Now, write down a spatial point. Angular displacement is a vector quantity. Angular displacement is a vector quantity only if it is very, very small. Angular displacement is a vector quantity only if it is very, very small. Now, थोड़ा सा समझना, this theta and all, we are artificially developing these things so that we can simplify circular motion. आप बिना एंगुलर डिस्प्लेसमेंट एंड ऑल के क्वेश्चंस को हैंडल कर सकते हैं, लेकिन हम नहीं करना चाहते. हमने यहाँ पर कुछ स्पेशल चीजें डेवलप की हैं इजी बनाने के लिए. दे आर काइंड ऑफ आर्टिफिशियल वेक्टर्स. इसलिए हमने अपनी तरफ से फोर्सफुली एक कंडीशन डाली हुई है सो दैट वी कैन डिफाइन समथिंग एल्स लेटर ऑन. इट्स मैथमेटिकल कंस्ट्रक्शन बेसिकली. लेकिन आपको फील कराने के लिए लेट मी आस्क यू दिस. लुक एट द बोर्ड. इफ आई मूव along the straight line, if I follow the edge of the board, if I follow this, if I move straight, is there any angular displacement present? Yes or no? As I move along the straight line, is there any angular displacement present? Yes or no? Write down this in the comment box. Well, that's what I expected from you, that everybody will write no. The answer is depends. Depends. और आदमी ने क्या लिखा हुआ है? No. अब when I say depends, क्यों? देखना. If you are looking at this lecture in your mobile or desktop or anything, अभी मैं कहाँ पर हूँ यहाँ देखना, and keep your head and eyes focused at this initial position. And then as I move, did you notice that you had to rotate your face from this position to this position. Initially I was over here and then I went there. In the whole process you had to rotate. आपको देख सके, आप मान के चलो कि आप मैं हूं यहां पर. So I'm looking at this and then I have to look over here. As the object moves, आपने क्या notice किया? An angular displacement. But is there any circular motion present? No. मेरा path कैसा था? Straight. लेकिन आपको अपना सिर rotate करना पड़ा. Now imagine a second observer. और वो ऑब्जर्वर यहां पर है, जस्ट इस पोजीशन पर. इमेजिन कि एक आदमी यहां पर खड़ा हुआ है. अब जब मैं इस तरफ मूव करूंगा तो फिर जो आदमी यहां है इसको अपना सिर रोटेट करने की जरूरत नहीं है, घुमाने की जरूरत नहीं है. जो आदमी यहां पर है, जैसे जैसे ऑब्जेक्ट चलेगा वो कहां देख रहा है? सामने. And therefore this observer, he doesn't have to move his head, rotate his head. लेकिन एक ऑब्जर्वर जो यहां पर है, somewhere here, उसको इस ऑब्जेक्ट को देखने के लिए he has to rotate his frame. That means even in a straight line path, you just saw we can create what? Angular displacement. हमारी मर्जी, हमने कर दिया. Do we necessarily need this angular displacement from this side? No, we do not. You can simply answer everything with the help of V equals U plus AD, S equals UT plus half AD square, assuming I am moving with constant acceleration. There is no need for theta and all. But for this type of path, introduction of theta will simply complicate things. Calculation बढ़ जाएगी. यहां पर ज्यादा आसान क्या है कि भाई सीधे सीधे जा रहा है, सीधे सीधे सॉल्व कर दो, v equals u plus AD and all से. लेकिन यहां पर x और y में रिजॉल्व करना खतरनाक हो जाएगा, इसलिए हमने यहां ये आर्टिफिशियल थीटा का कॉन्सेप्ट डेवलप किया हुआ है. फर्स्ट टेल मी, डू यू अंडरस्टैंड दिस चेंज ऑफ परसेप्शन for this observer and this observer? Although path was straight line, this guy says, somebody standing over here, that yes, an angular motion is present, but somebody over here, he says that no, there is no angular motion. Yes or no first? Well, these are basics of physics. जब ये क्लियर होते हैं तो फिजिक्स समझने में मजा आता है, वरना केवल रटने वाला काम अगर करना है तो फिर आप कुछ भी कर सकते हैं. Look here. So you started from this position, you arrive at this position, and then I told you that this theta, which is called angular displacement, is not always a vector. It is a special thing. It is a vector only if it is very, very, very small. That is like d theta. किसी ने आपसे बोला 45 डिग्रीज, क्या 45 डिग्रीज वेक्टर है? अपन ने बोला नहीं. इज 0.00000000045 डिग्रीज, इज इट अ वेक्टर? विल से यस. क्यों? बिकॉज दैट्स हाउ मैथ्स विल बी डेवलप्ड लेटर ऑन. अदरवाइज थीटा जरूरत ही नहीं थी. हम v से ही काम चला सकते थे, ध्यान रखना, हम v से काम चला सकते थे vx vy से. तो हमने अपनी मेहनत बचाने के लिए किया है. होपफुली इतना पार्ट आपके दिमाग में फिट हो गया है. नाउ जब हमने डिस्प्लेसमेंट डिफाइन किया था, तो आफ्टर दैट वी यूज्ड टू डिफाइन व्हाट? रेट ऑफ चेंज ऑफ डिस्प्लेसमेंट. जैसे हमने थीटा डिफाइन किया, after that we define rate of change of theta. So what is rate of change of displacement? Velocity. So what is rate of change of angular displacement? Angular velocity. So write down the heading angular velocity. Write down the statement. Rate of change of angular displacement. Rate of change of angular displacement is called angular velocity. It is represented by omega, which is nothing but W. It is represented by omega and is d theta by dt. And if you wish, you can now write like this. But mostly you will find that it's in this form. Now you know that d theta, what is d theta? Small angular displacement. Small angular displacement is a vector. Omega is always a vector. Why? Omega is what? D theta divided by dt. So omega is always a vector. But theta, angular displacement, is a vector only if it's very, very small. Avoid, to save time, you'll find that we don't use these things. और क्यों नहीं करते हैं, चीजें क्लियर हो जाएंगी. Now, ये जो omega है, हमने बोला कि what is omega? It is a vector, and if it is a vector, then it must have direction. So if it has direction, then what type of direction do we have? Who will tell me? An object is moving like this. You can see. Just asking if somebody has done circular motion, or maybe you have already the idea of angular velocity and all. So for this circular path, if I ask you what is the direction of angular velocity, then how will you answer this? Is there anyone who can answer this part? One of you was saying no, and I forgot for what you're saying no. Somebody wants me to repeat something, but I have forgotten that what was the original question I asked. So I'll send you the recording. Listen again, and you will understand this. Write down the statement. Angular velocity is a vector quantity. Angular velocity is a vector quantity and its direction is along the axis of rotation. Special चीज है. Angular velocity is a vector quantity and its direction is along the axis of rotation. Do you know what is the axis of rotation? Look, if your object is moving like this, normally you call it what? Clockwise motion. No, anti-clockwise. This is what? Anti-clockwise circular motion. Anti. Now for circular motion, this is the axis. I hope you can see. The axis always runs through the center. This is the axis. Now how do we represent axis? You represent axis like this. This is the axis. And I said angular velocity is a vector whose direction is always along the axis. Why? देखना. Take your right hand. What type of rotation do you see? Anti. I am holding my hand like this. I hope you can see this. That's how I'm holding my hand. I'm keeping my thumb perpendicular to the palm. So when you say anti-clockwise, the thumb is coming out. Thumb is coming out. And therefore, we say that angular velocity is acting along the axis. अब सुनना, मैंने बोला कि ये ओमेगा एंड ऑल, थीटा एंड ऑल केवल सर्कुलर मोशन को समझाने के लिए बने हैं, ये थे नहीं कुछ, हमने आर्टिफिशियली क्रिएट किए हुए हैं. Now imagine कि the first person who developed concept of omega, the first person, suppose, had he been a left-handed guy, तो वो क्या बोल रहा होता? तो बोलता कि भाई एक काम करते हैं, मेरे लिए तो रोटेशन ऐसा है, this is my left hand. If I hold my left hand like this, then thumb is pointing in. It is along the axis, but direction is what? In. But since most of us, we are always right-handed, no offense to anybody left-handed, just I'm giving a statistical idea that if the first person was left-handed, तो फिर अपन सब क्या बोल रहे होते? Angular velocity is along the axis, कहाँ पर है? In. But if I use my right hand, then angular velocity is along the axis. That's how I define it. Because for me, angular velocity is basically what? Anti-clockwise. Objects can either rotate clockwise or anti-clockwise. You've got two options. Two. Anti or clock. So, let's use the right hand. If I curl along the rotation, then thumb is pointing along the axis, and I say that angular velocity is along the axis coming out. Which means if rotation is like this, अब दोनों फिगर को side by side draw करना. If rotation is like this, then this is the axis, but this time omega will be shown as a cross. Why as a cross? Look at my right hand. Curl. This is clockwise. Curl and thumb is pointing in. This gives us direction of omega. Along the axis, inwards. Along the axis, out. क्यों हमने ये सब डेवलप किया हुआ है? Because it's an artificial concept. If I'm moving right side, if I'm moving this way, if you ask left-handed guy or right-handed guy, they both will say, भाई सर कहाँ move कर रहे हैं right side? But in this case, somebody using different hands will end up with different velocities, and therefore we need to fix a benchmark. हमने क्या define किया? Write down that. जो हमने define किया. Direction of angular velocity is decided with the help of right hand. Direction of angular velocity is defined with the help of right hand. If it is anti-clockwise, then angular velocity is along the axis and out of the plane, out of this circular plane. If rotation is clockwise, then angular velocity is along the axis but is pointing inside. Is pointing into the circular plane. ये सब क्यों हमने बनाया? क्योंकि अपने को एक चीज पता है कि भाई वेक्टर्स को अपन कैसे दिखाते हैं. वेक्टर्स को दिखाने का तरीका क्या है? स्ट्रेट एरोज, स्ट्रेट एरोज. और वेक्टर्स को दिखाने का तरीका ये नहीं है कि भाई हमने वेक्टर्स को ऐसे दिखा दिया, बिकॉज दिस थिंग हैज डिफरेंट डायरेक्शंस. इसलिए हमने क्या कॉन्सेप्ट डेवलप किया, हमने बोला कि यार यहां पर ये सब झंझट हटाओ कि क्लॉक एंड ऑल, उसकी जगह आप क्या डिसाइड करके बताना शुरू कर दो कि जो रोटेशनल सेंस है, द वे थिंग्स आर रोटेटिंग, instead of defining clock and anti-clock, you can also say out or in. What I am saying is this. I'll ask you this. An object is moving in a circular path. An object is moving in a circular path with angular velocity 8 k cap. And I forgot to mention the unit. इतना पता होगा भाई आपको, यूनिट इज रेडियंस पर सेकेंड. यूनिट ऑफ एंगुलर वेलोसिटी इज व्हाट? रेडियन पर सेकेंड. So if I say that angular velocity is 8 k cap, what type of circular motion is it? Clockwise, anti-clockwise? Write down fast. Last few things. What type of circular motion we are talking about? Clock or anti-clock? Angular velocity is given as 8 k cap. और टाइम लग रहा है भाई. If I say k cap, what is k cap? This is I, this is J, K is out. The moment I say K cap, it tells you that keep your right hand thumb out. K cap out, keep your right hand thumb out. Look at the curl, anti-clock. That's it. This is the sense of rotation. What type of sense you see? Anti-clockwise. That's how you define omega and all. Now एक बार और देखना, किसी ने हमसे बोला कि भाई सर्कुलर मोशन इस तरह का हो रहा है, जो अपना ओमेगा है, दिस इज माइनस ऑफ 5 k cap. यूनिट इज रेडियन पर सेकेंड, आप लिख सकते हो. द मोमेंट यू से माइनस 5 k cap, 5 is giving you the magnitude. And you know what minus k cap is? Minus k cap means thumb is inside. Thumb inside. See the sense of rotation. It's coming what? Anti-clock. Oh, sorry. It's coming what? Clock. So this is the rotational sense, which is clockwise. Now last thing. क्यों हमने v की जगह पर ओमेगा डेवलप किया सर्कुलर मोशन में, वेलोसिटी की जगह एंगुलर वेलोसिटी का कॉन्सेप्ट डेवलप किया? अब जरा इस पार्ट को समझना क्लियरली विद द हेल्प ऑफ दिस यूनिफॉर्म सर्कुलर मोशन पार्ट. अच्छे से सुनना और बताना बाद में कि आपको समझ में आया कि नहीं. अगर एक आदमी सर्कुलर मोशन को इस तरह से यूज करता, look at this simple example. If I ask you that object is moving with constant speed, देखना भाई, if object is moving with constant speed, जब यहां पर है say 5 meters per second, जब यहां पर है 5 meters per second, जब यहां पर है 5 meters per second, right here 5 meters per second. Now tell me how many values of velocity vector we can create. Velocity vector we can create for this circular motion. Write down fast in the comment box. How many v vectors? Good. Infinite. What is this? 5j cap. What is this? 5 minus I cap. What is this? 5 cos theta I, 5 sin theta j with proper plus and minus. So how many components we can have? Infinite. But अब मैंने आपसे बोला कि यार इसकी जगह पर इनफाइनाइट वैल्यूज पुट करने की जगह पर एक काम करो ना कि ये जो ऑब्जेक्ट है ये आपका 5 से जो रोटेट कर रहा है, आपने बोला इन द सेम फिगर, आपने बोला कि ये जो ऑब्जेक्ट है ये किस तरह से रोटेट कर रहा है एंटी क्लॉकवाइज. सुनना, यहां कैसा है? एंटी. ओवर हियर एंटी, ओवर हियर एंटी 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 एंटी. तो हर जगह डायरेक्शन क्या है? सेम. और अगर स्पीड सेम है तो आपको इतनी अकल होगी अभी, अगर स्पीड सेम है तो जो एंगुलर रोटेशन है यहां का, यहां का, यहां का, यहां का, everywhere it will be same. Somebody trying to write omega as a vector will use some magnitude. थोड़ी देर के लिए बोल दिया मैग्नीट्यूड 4 है, मान लिया, बाद में चेक करेंगे मैग्नीट्यूड क्या होगा. उसने क्या बोला? क्या मैग्नीट्यूड है ओमेगा का? 4. डायरेक्शन क्या है? एंटी. एंटी मींस थंब किधर आ रहा है? बाहर. बाहर मतलब क्या? के कैप. That's all. With the help of a single vector, we can define angular velocity at each and every point. Had it been v, which we are using in previous lectures and all, then we will have to take infinite values. तो हम फिजिक्स में करना क्या चाहते हैं? अपनी मेहनत कम करना चाहते हैं. कौन इनफाइनाइट वैल्यूज यूज करेगा? हमने बोला यार दोनों सेटअप सेम ही है, कांस्टेंट स्पीड से रोटेट कर रहा है. अगर मैं v वेक्टर डिफाइन करूंगा देन आई हैव टू टेक इनफाइनाइट वैल्यूज. हटाओ यार इसको, इससे बात करेंगे हम. यू गॉट अ यूनिक वैल्यू ऑफ v. यहां का ओमेगा 4k कैप, यहां का 4k कैप, 4k कैप, 4k कैप, 4k कैप. If you understand this much, then write all yes in the comment box and then you can leave. Thank you very much.
Excuse me, sir.
Yes.
Sir, can you please explain the part when you said that when the angle is very small, so it can be taken as a vector?
Just by convention we have defined that whenever theta is small, if theta is large, what is theta? First of all, it's a pseudo vector. It's not a vector which we always see in nature. It's something which is artificially created. So when you define something artificially, you have to add some restrictions. And why do we need to add some restrictions? Because for large values of theta, it doesn't obey triangle law of vector addition. Do you know what triangle law of vector addition is?
Yes, sir.
So those things which obey triangle law of addition, they are only called what? Vectors. What I am saying is this: if you rotate something by 90 degrees, I don't know, you can try this thing on your own also later on. So if you rotate a vector, or just take this marker, if I rotate this thing by 90 degrees, I'll call it 90 degree k cap. Rotation, this is k. So this is 90 k cap. And then what I did, I rotated this thing in this direction. It will be called 90 I cap. And then I rotated this thing this way. It should be called 90 j cap. But you can see that ultimately this black marker is aligned with the blue marker. I don't know you can feel this thing or not, but let me try again. If I rotate both markers, blue and black, initially they are pointing in the same direction. But if I rotate this way, Look at the rotation. And what I told you, what is direction? This. So this direction which is coming towards you is k cap. This is coming 90 k cap. When I rotate like this becomes 90 I cap. When I rotate like this, it becomes 90 j cap. So if you add all three, you get what? 90 common, I plus j plus k. But it is not 0. Whereas the marker has arrived to the same position. And therefore we found that it doesn't obey that triangle of addition if values are very large. But we need to define angular velocity. We need clockwise, anti-clockwise, these senses. So what is omega? We are basically interested in omega part, omega. Because we want to limit the values of v we can have. So there are two values of omega, either anti or clock. And what is omega? d theta by dt. To make omega vector, I need to have d theta also as a vector. अब इतनी डिटेलिंग की जरूरत नहीं है बेटा आपको, but since you asked, I have told you. Are you satisfied?
Yes, understood.
Okay.